All right, so today we're going to talk about the basic rules of derivatives, and then most of the video, or this video, will be going through some examples and practice with taking the derivative of different types of functions using these rules. Let's start with the most basic rule that we talked about, and that is the power rule of integration, or power rule of differentiation, sorry. And that is when we take the derivative of a polynomial function x raised to some power n, the derivative of this is n, x to the n minus 1. So you bring the n down and then you subtract whatever n is equal to. Second rule is the chain rule, and that is when we have the derivative of the composition of two functions. And so if I have the derivative of f of g of x, the derivative is f prime g of x times g prime of x. So it's basically the derivative of the outside, and then you multiply it by the derivative of the inside. Number 3, I'm going to write this a little bit different, just because I think it might be a little bit easier to write it in this notation, and that is without the x's. If I take the derivative of the product of two functions, this is equal to f prime g plus f g prime. Okay, these are both functions of x, so I could write f of x and g of x, but just to keep it simple, I'm going to just write f and g. And then similarly, if I take the derivative, instead of the product of two functions, if I take the derivative of the ratio, or the quotient of two functions, that is low function d high minus high d low, or derivative of the low, square the bottom, and away we go to number 5, which is the derivative of the natural log, and that is 1 over x. Okay, so here are the 5 rules that we've seen throughout the year. The hard part, I think, about differentiation is just recognizing how a lot of the times you're going to have to combine rules together, and so that's going to be the tricky part, is using multiple rules at the same time, and how you kind of do that to approach a certain question. So let's start with some examples. Example 1 is going to be okay, and then example 2 is going to be a little bit more challenging, especially with the simplification. So starting with example 1, if I have a function that is defined as a radical, that's the square root here, another way to write this is x squared plus 8 to the 1/2. And this is the notation we're going to want to use when we're taking the derivative of functions, because it's going to make it easier to use the power rule. So the derivative of this, we bring the 1/2 down to the outside. The inside stays the same. And then we multiply everything by the inside, the derivative of the inside. So you can kind of think of this as f prime g of x, and this is g prime of x. And then we can simplify this. So the 2's will cancel, and this becomes x over x squared plus 8. And that's going to be the derivative of our first function. Okay. So the second one's going to be a little bit more challenging, especially with its simplification, like I said before. Because we're going to be dealing with a few different rules kind of tied together. And so let's find the derivative of number 2 here. So number 2, because we're taking the quotient of, or the ratio of two functions, we're going to use the quotient rule. And so let's start by writing, and what I'm going to do here is let's use, instead of writing the square root, I'm just going to use to the 1/2 power. So let me actually just rewrite this first, sorry. So instead of x over the square root, I'm going to write x over this whole expression to the 1/2 power. Okay, now let's take the derivative of this. So f prime is going to be the low function times the derivative of the top, which is just 1, minus x high d low. And now let's find the derivative of the denominator, which is going to be a little bit more challenging. The 1/2 will come down, 1 minus the natural log of x squared to the negative 1/2, and then we're going to multiply this by the derivative of the inside. Well, to take the derivative of the inside, to take the derivative of this, we need to use the chain rule again. So we end up with negative 2 natural log of x times, I'll write this all in one parenthesis, natural log of x times 1 over x, like that. Okay, so we get this absolute mess of a numerator. And then the denominator is just going to be 1 minus natural log of x. Well, what we're doing here is we're taking the denominator here and we're actually squaring it. We're squaring that. So eventually the 2's right here, these will cancel each other out. Okay, but I'll write that in the next line. All right, so let's simplify this a little bit. We're going to mainly focus on the second term in the numerator, which is this term. And so these x's will cancel. Remember, this is all multiplied together. And the 2's will cancel. And then this negative right here is going to change the sign over here. Okay, so it's a little messy, but it should clean up a little bit. Here's our first term again. And we get plus 1 minus the natural log of x squared to the to the negative 1/2 times the natural log of x over 1 minus natural log of x squared. Okay, this is technically the derivative, and so if you want, you can leave your answer like that. What I want to do though is I just want to simplify a couple more steps. This should show you how we can kind of rewrite these expressions. So this will stay the same. What we can do here is rewrite the second term as the natural log of x over 1 minus the natural log of x squared to the 1/2, so that this term becomes, it goes into the denominator. And this will stay the same as well. Let's write it like this. Okay, there's, again, you can keep going to simplify this. Let's actually just stop right here. I think this is a good place to stop. Like what we could do is multiply by 1 minus natural log of x squared to the 1/2 over itself to get rid of this complex fraction, but for the sake of just going through this example, I think that's a good spot to leave it. All right, so let's go through some practice questions. And what I would encourage you to do is, before I go through each of these, I would encourage you to try these on your own. There's more than one way to do each of these. All right, and so if you do a different approach and you get the right answer, that's totally fine. So the first one, the easiest way I think to approach this one is to actually rewrite it first. You could try to approach it with the quotient rule, but if you can avoid using the quotient rule, definitely try to do that, because it's a little messy and there's a lot of terms you have to deal with if you have to use the quotient rule. So we can do for the first question here is split this up into two terms, where we have x squared over x minus 1 over x. So this can be broken up into two fractions, which can be simplified to x minus 1 over x, which is the same thing as x minus x to the negative 1. And this is actually the, this right here is the way we want to write this, because we're going to be using the power rule of differentiation. And so we want to write it as x to like a negative number. Just it'll make taking the derivative a little bit easier. All right, so now let's take the derivative. So we've rewritten the function, and so the derivative of this is then going to be the derivative of x, which is 1, plus the negative 1 will come down. The negative 1 will come down, become positive x to the negative 2. And so this becomes 1 plus 1 over x squared. That's going to be our answer for this one. All right, number 2. Again, there's a couple different ways to approach this. One is you can use the product rule here, but I think an easier way to approach this one is actually combine these together first and then take the derivative using the power rule. So you could use the product rule here, but let's actually combine this together into one term first. So we have 3x squared times x to the 1/2. Well, this is the same thing as 3x to the 4 over 2 times x to the 1/2. Remember, if we are multiplying two terms with the same base, the exponents will add, and so this becomes 3x to the 5 over 2. So we've simplified these terms now, and now let's get to this is an easy point that we can take the derivative now. So this gives us the derivative of 15 over 2, if we bring the 5/2 down, x to the 5/2 minus 2, which is x, 5/2 minus 1, sorry. So it's 5/2 minus 1, which is 3/2. And so this is the value of the derivative for number 2. And then lastly, number 3, for our practice problem set. Again, there's a few different ways you can approach this. Let's do it. Let me go through the two different methods that you can do. So I think the hard way to do this one is to use the derivative of the natural log plus the chain rule plus the product rule. So the derivative of this, let's start with the derivative of the inside, is e to the 7x plus, this is using the product rule, x times 7 e to the 7x. Okay, so this is a combination of the chain rule and the product rule, times 1 over x e to the 7x. And then what we can do is distribute this term to both of these. And so we end up with 1 over x plus 7. Another way to do this question is to approach it through a couple of properties of logs. So we know that we have two terms inside a log statement that are multiplied together. We can rewrite those two terms like this. Okay, so I haven't taken the derivative yet. So these are equivalent statements to one another. Well, this right here just becomes 7x, plus 7x because the natural log and Euler's number e are inverse functions of each other, and so they cancel each other out. Now the derivative of this just becomes 1 over x plus 7. Same thing as we did, same answer as we got over here. Okay, just a different method. So a lot of the times there are there's more than one approach to each of these questions. Okay, I would encourage you to use the approach that reduces the amount of algebra you need to use to solve that particular question. Okay, and let's wrap up this video by going through problem set number 1. And so let's find the derivative of each of these three functions. So number 1, Again, you could try to use the quotient rule here, but it might be easier to simplify it first. So let's simplify this by splitting up into 3 fractions. So 2x to the 4th over x squared plus 3x squared over x squared minus 1 over x squared. Okay, and so we end up with 2x squared plus 3 minus x to the negative 2 if we rewrite it. Now let's, this is a good spot that we could take the derivative of each term individually. So if we do that, this becomes 4x plus x to the negative 3, which can be rewritten. Sorry, there should be a 2 right here. Plus 2x to the negative 3, which can be rewritten as 2 over x cubed. That's the first one. Okay, a couple more. This one is similar, but it's different than the second question from our practice, and that is you could use the product rule for number 2 in our practice problem set, but this one you have to use the product rule. Okay, there's no way to combine these two functions together. And so the derivative of number 2 is then just 3x squared times, I'll write it like this, 2 minus x to the 1 over 5. That's the first term. And then the second term is going to be x cubed times the derivative of g, which is 1/5, 2 minus x to the negative 4/5 times negative 1. And then we can rewrite this by bringing the negative to the front. So we get minus x cubed times, well, let's write it like this. Again, you can simplify this. X cubed over 5, 2 minus x to the 4/5. So here's the derivative for number 2. Alright, and let's wrap this up by going through the derivative of the last question. So let's rewrite this. So f of x is equal to 2x minus 4x to the negative 1/2. And so the derivative is 2. And the negative 1/2 will come down. And we get plus 2 x to the negative 3 over 2. Okay, and if we want to write this as a radical, the derivative becomes 2 plus 2 over the square root of x cubed. Okay, and that's the answer for problem set 1, number 3.